Now we'll see the mathematical model and simulate this model toy train. This toy train is divided into two parts, this main engine and this cart. So I will divide them first. This is the engine and this is the cart. Suppose the mass of this engine is m1. The mass of this cart is m2. We will be applying a force which is our input at this direction. This is F. Then the displacement of this engine will be x1. For this mathematical model, the rolling resistance forces are modeled as being linearly proportional to the product of the corresponding velocities and normal forces, which are equal to the weight force. So F will be mu m1 g, and there will be a velocity. For this particular model, I am considering velocity because the velocity and the product of the normal force are proportional to the friction force. In the same way, for cart 2, the rolling friction will be mu m2 g and this velocity. Here I am considering a spring with a stiffness k. So the force will be k into x1 minus x2. The displacement of the cart is in this direction, which is x2. I am combining these two in the spring. So these are all my equations or variables. From all this, I have to create a mathematical model. What is the summation of F1? F1 first, this force is bigger, so F minus the spring force K into x1 minus x2, and the rolling friction, which is mu m1 g x1 x1, or you can say velocity. Again, I am saying that this m1 g is the normal force which is affecting upward, and x1 is the velocity. Don't think this too hard about the velocity, because in this model the rolling friction is just proportional to the product of normal force and velocity. The original law is friction is equal friction coefficient into normal force. This is the original equation. What is F2? F2, here main force is K x1 x2, which is affecting in this direction. For this force, this cart will move. Then K into x1 minus x2 minus this rolling friction mu m2 g x2 per velocity. Now from all this, I have to make a Simulink model. This all is the summation, means m1 into x1 double bar, which is the common law, because we know from second law F is equal ma, and here all this summation is equal will be m2 x2 bar. I am giving a resultant of force del F1, which mean m1 x1 double bar. This is for the first system. If I multiply a factor which is 1 by m1, what will you get? x1 double bar, which is the acceleration. If integrate the acceleration here 1 by s, then we will get velocity x1 bar. Again, if we integrate this, we will get displacement. Now in the same manner for the second system, here I am giving a force del F2, which is M2 x2 bar. Again, from all these steps, we will attach a scope in the end. Here I will include a block. Now, what was the primary force of the engine? It was the F force. So I will include the signal generator. From here I can give F. I will give a square input. First I will subtract this mu m1 g x1. So x1 I will get from here. Here I will multiply again, which is mu m1 g, and I will subtract this. I need to subtract this k x1 minus x2. So I will take 2 points here and here. X1 will be added and x2 will be subtracted. From here we will subtract in the first model. So first model is complete. I hope you understood that why I started from this resultant force, because at the initial position the system was incomplete and I needed these variables x1, x1, x1 dash, etc. So I started from this resultant force. There was a mistake at first, because when I subtracted these two, we get x1 minus x2, obviously, and we must need to multiply this with a gain k and then subtract it from here. So this here is k x1 minus x2, and I need this in the system too, so I will add this in here, and for minus I need to subtract this dash. I need this x2 dash and multiply with mu m2 g and subtract it from here. So this is basically the Simulink model. It is quite messy, but I will elaborate it much better in the Simulink window. From here I will take a scope. This scope will show us the velocity profile. So what we are actually doing, we are giving square wave, right, in a manner of force. So suppose here is the train. When the force is positive, the train will move in this direction, right? And when the force is negative, the train will move the opposite direction and go back to its initial position. When train is moving in this direction, what will be the velocity? The velocity will rise at first, then it will become constant, and when the train become reach this position, and again it will went back to in the initial position. So the velocity will then become also negative because we know it's a vector. So let's all see this in the Simulink window. Go to Simulink. Now I need some adders. So now I also need a gain. So search gain. Make it bigger. So the gain will be 1 by m. Gain is equal 1 by m. 1. Apply OK. So why the red color is showing? Because the m1 variable is not defined. I need integrator 2 actually, and I need exactly this model another time. So copy and paste. This is 1 by m2. Well, let me define this. These are accelerations, these are velocities, and these are displacement. These values are not actually inputted, these are just annotations for easier understanding. So here I need scopes. So search for scope. Okay. Here I need one summation and two subtraction. So double click this in the list. Change this to plus, minus, and minus. Hit apply. Okay. I need a signal generator here. Search for signal generator. From here I will give F force. Now I need to subtract the rolling friction. So I need a gain first. Here the value will be mu. I'm denoting m as mu into g into m1. Apply. Okay. And I need a velocity from here. Okay. Good. And subtract from here. Now I need the force for the spring. So I need another gain. This need to be inverted. So Control I. The term will gain will be K. Hit apply. Okay. And I need a subtractor. Sub Control I. So x1 will be subtracted from x2. Sorry, x2 will be subtracted from x1. So this all is x1, sorry, x2. Here x2. Okay. Okay. So plus will go to x1, minus will go to x2. So x1 minus x2 and into k, and this k will be subtracted here. This is basically Fs. In the system 2, the main force was Fs. So draw a line from here and subtract the rolling friction. So here that sign will be negative, positive and negative. Apply. Okay. I need another gain like this, so I'll copy this, just invert. Where is my Fs? This Fs will go here. Alright. So this M1 will change to M2. Apply. Okay. And from x2 the velocity, will take velocity from here and subtract here, and we want to see the velocity profile, so we'll take another scope and add here. I need to put the values of m1, m2, k, f, mu and g. So I will return to MATLAB and put the values here. 1 means 1 kg, k is Newton per second, our input is 1 Newton, our mu is 0.02 second per meter, and g is 9.8 meter per second. So sorry, this is just a command window. I have to take a script. So new script and write this here and run and advance. Okay. So in the workspace we can see the all values are assigned to the variables. So go to the Simulink, run here. We can see the red marks are gone. So the Simulink has automatically read those values I have assigned. To manipulate the function generator, I will give a square wave and the amplitude will be -1. Why -1? I will come back to that. And frequency will be 0.001 hertz, and this will be hertz. Apply. Okay. I will take another scope from this function generator. Alright, so let's run it. And here we can see the velocity profile. Here we can see that the train has the initial velocity of 3 point something, and it was constant at some point, and when the train was returning to its original position, when we applied a negative force, then it became then the velocity also became negative, which indicates the train is moving in the backward. So let's see the force profile. Here you can see that the force is square wave. First, for 500 second we are giving a positive force. Okay. Then at this instant we are giving a negative force. So this is the velocity profile. If you want to see the acceleration profile, use another scope. So this is the acceleration. First, we applied a force. So there is a acceleration, and throughout 500 seconds, the acceleration was 0. Why is that? Because the velocity was constant. And in this 500 seconds, we applied a negative force. So the acceleration become also negative, and from here on out, it becomes 0 because of the constant velocity. And for this part, why I have taken amplitude -1. So take amplitude +1. Now see what will happen. Run this again. Scope 3. You see, when I have taken amplitude 1, the signal started from the -1. This is a default thing in Simulink. So you have to be careful of this. Always take amplitude -1 to get the initial condition from the positive side. And what will happen to the velocity? Let's see. The velocity become this as expected. So here is the overall overview. If you have any questions, please write those in the comments. I will try my best to answer those.